Okay, for our final video in the dynamic section, we're going to be looking at friction. And for this, we're going to be looking at the friction worksheet. And once again, we're going to use and assume that G is equal to 10 meters per second squared. Again, that's just to make our math a little bit easier. Normally we'll use 9.81. So, all right. So it says applied force of 50 newtons is used to accelerate an object to the right across a frictional surface. The object encounters 10 newtons of friction. Use diagram to determine the normal force, net force, mass, acceleration, Okay, so if we look at this, we know that we have a force of gravity acting on it of 80 newtons. Okay, this thing is, again, you can assume it's sitting here on the floor. It's being pushed to the right. Okay, so this thing is moving that way, what that doesn't mean is it's not falling down to the floor. It's not flying up off. So because of that, the normal force is going to have to equal my force due to gravity. And that's because the net force has to be 0 in the vertical direction. The box is not flying above the floor. It's not being sucked down in. The other thing, too, is I can find out the mass. The mass I can find by taking the force due to gravity is equal to the mass times the acceleration of gravity. So 80 newtons. My mass is what I'm looking for. And G, remember, we're going to use that, is 10 meters per second squared. Just to make the math easier. Because if we go 80 divided by 10, it's going to give you a mass of 8 kilograms. Now, they want the net acceleration, but before we can find the net acceleration, we have to find the net force. So if we look at all of the forces applied here, and we're going to kind of highlight these, we got the force of gravity pulling down, and the normal force going back up. 80 down, 80 up, they're going to cancel each other out. I'll change highlight colors here. And so you got the force applied is 50, the frictional force is 10. Now, because they are vectors, we're going to add them up, but because they're equiparallel, we're actually going to subtract them. So my net force is going to be 50 minus 10, or 40 newtons. My acceleration now, if I want to find the net acceleration, that's straight from the Newton's second law of motion, A net is equal to F net divided by the mass. And so my net acceleration is going to equal my 40 newtons, because that's my net force, divided by my mass, which is 8 kilograms. So it's going to be a net acceleration of 5 meters per second squared. And so we'll put that right in, 5 meters per second squared. Now the next one here, very similar. Okay, applied force of 20 newtons, use accelerate an object to the right across a frictional surface. Okay, diagram determine all the other good stuff. So once again, we'll start with the easy one. We've got gravity here. Gravity is equal to 100 newtons. Because this thing isn't falling down through the floor or flying up off, we can say that our normal force is also 100 newtons. Okay, we can find our mass, because I remember the force due to gravity is equal to the mass times the acceleration of gravity. So 100 newtons is equal to my mass times, I jumped the gun, my mass times the 10 meters per second squared, again, just for this worksheet. So my mass is going to end up being 10 kilograms. Now, I can also find my net force, because once again, I know the force of friction and my applied force. So my force of friction is going to be 10 newtons, and my applied force is 20, and so my net force is going to equal the difference of those two. In this case, 20 minus 10, so my net force is going to equal 10 newtons. Again, I can find my net acceleration. A net is equal to the net force divided by the mass. So we just decided that my net force was 10 newtons. We previously decided that my mass was 10 kilograms, so my net acceleration of this particular thing is going to be 1 meter per second squared. 1 meter per second squared. Now, the thing we didn't talk about yet was this mu. And this is our coefficient of friction. And for this, we have two different ways. One, we can go to our reference tables. And if we know what the materials are, some of those are listed in our reference table. Here, they don't tell us if it's wood on wood, is it ice on rubber, or is it Teflon on Teflon. We don't know that. So we have to use the other way, which is the force of friction is equal to mu times the normal. So my force of friction, that's 10 newtons. My mu is what I'm looking for, and my normal force we decided was 100 newtons. And so my mu, when you cross multiply divide here, you get mu as being 0.1. So 0.1 is my coefficient of friction between those two surfaces. All right, and our last one, we've got a 5 kilogram object sliding to the right, encountering a frictional force, slows it down. Coefficient of friction, between the object is 0.1. Determine the force of gravity, normal force, blah, 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 blah. Okay, so going through here, let's start off with the force of gravity. My force of gravity, I can find by taking my mass times the acceleration of gravity. So my mass, 5 kilograms, times my acceleration of gravity, which, again, for this one, 10 meters per second squared. So my force due to gravity is going to be 50 newtons. Once I know that force of gravity, I look and say, oh, okay, well, there's no other vertical forces acting on it with the exception of the normal force. So the normal force has to be pushing that up. So that has to equal 50 newtons. 50 up, 50 down, because the box isn't being sucked down into the ground. It's not flying up off. We know they have to be in equilibrium. 50 up, 50 down. The next thing I need to do is find my force of friction, because I can't find my acceleration without knowing the net force, and I can't find the net force without knowing what the force of friction is. So I got to find my force of friction next. So from up here, remember, force of friction, if it's not given the type of materials, we got to use this. Force of friction is mu times the normal. So my force of friction, they tell me that mu is 0.1. My normal force is 50 newtons. And so that tells me that my force of friction is 5 newtons. So now coming back down here, I look and they want me to find out the net force. Well, my 50 up and my 50 down have canceled out. The only one I'm left with is the 5 newtons. 5 newtons is the vector sum of all the forces acting on it. So my net force must be 5 newtons. Okay? Technically, if you want to talk about it, because it's working on slowing it down, it would be a -5 because it's opposing the motion. This object is traveling to the right, it tells us. That's its velocity. This force is working on trying to slow it down. So technically, it's going to be negative. And I probably should have put those all the way up there as well. So if I want to find my net acceleration, I'll change colors there. Net acceleration is just by taking the net force and dividing it by the mass. So my net force is a -5 newtons. My mass is 5 kilograms. And therefore, my acceleration is a -1 meter per second squared. So -1 meter per second squared. Okay, so just a little short introduction into the friction forces. Hopefully this helped. And if you have any questions, don't hesitate to come see me. Have a great day. See you, bye.